Hello, and welcome back to this Unity tutorial, where we're going to be taking a look at the first-person tutorial, Part 2. So in the previous tutorial, it was really exciting. We were able to get a gun attached to our player that could shoot out using Unity raycasts that actually was able to hit the player and be able to take damage. And we used a world canvas to be able to display the current health of the character. We're going to continue to build upon this, and I'm going to talk about some more fundamental concepts related to developing a first-person game, and also discuss some avenues that you should consider as you continue to further develop your game. So let's not waste any time and jump right on in. So taking a look at where we last left off, we have our first-person controller here, which has a gun that is childed to it. That is going to be underneath on the camera pivot, main camera, and sci-fi gun. What we're going to do now is we're going to go ahead and first add an audio source so that when you click to shoot, it makes a sound, and then secondly, when the bullet actually hits the player, we're going to instantiate a prefab at that location. Alright, so let's get started with sound. So the first thing we need to do is reference that gun script that we were working with before. So let's go ahead and open that up in Visual Studio. And I mentioned this briefly in the first video, but we're going to be adding an audio source, and we're going to be associating an audio clip with that audio source. We'll have a reference to it inside the code that I'm just about to show, and essentially when the user clicks the left mouse button, we want to play that audio source. So to do that, let's go ahead and get this set up. So what we're going to do is create a private variable. So private meaning that it can't be accessed from other scripts. The reason why we're going to make it private is because this audio source really doesn't need to be accessed from anywhere else. Only the gun script is going to be using it. Excuse these pop-up errors. Alright, so we'll say private, and we'll want to type audio source, and we'll just name this audio source so we know exactly what it's referring to. And then we'll have to bring our start function back. I know we deleted it last time, but in the start function, we have to be able to get a reference to the audio source. And let me explain this a little bit further. So, inside of this C# script, we're basically saying, hey, I want to be able to reference an audio source. This is basically just a label for it. But when we actually want to use the audio source that is physically attached to the gun inside of Unity, we actually have to go grab that audio source. Now, this script is going to be attached, or is attached, to the gun object, right? And we're also going to attach an audio source to that gun object. Because this script doesn't know anything about the audio source, the way that we get it to know about the audio source is saying, hey, I'm going to let you know about an audio source, and it's also attached to you. The way that you get a reference to it is by saying audio source is equal to get component audio source. Now the get component here works really nice because get component is going to look on the object on which this script is attached. So because this gun script is attached to the gun, it's going to look on the gun object for an audio source component. And that's all we need to do in the start function, is just get a reference to that audio source. Now we're going to, in the inspector, in a minute, we're going to add the audio source and attach an audio clip, so we actually don't need to do any configuration here inside the C# script. Now, you may, in the future, want to add multiple gun sounds, which is perfectly, very easy to do. What we can do is we can actually create public game objects, or public audio clips, I should say, excuse me. And if you do remember, public is going to allow these variables to show up on the inspector. So we can say public audio clip, and we'll call this bullet noise, or bullet shot, or something along those lines, right? It's going to be the sound that is played when the user fires the gun. And whenever we need to switch off, we can say, okay, audio source, the clip that you're currently using, I need that to be the bullet shot. And then we can come along and say audio source dot play. So now it will play the bullet shot sound. So this is what you're going to do if you have multiple different sounds. So we can copy this. Of course, we can change the name of it to something else, maybe bullet recoil. I'm not sure what you want to do with it, but I just want to let you know that you can do that. We're only going to need this play because I'm going to try and keep this as simple as possible. So we got the reference to the audio source component. Now, when the user clicks down here, now let's take a look at this logic just to remember what it is doing. If input.get mouse button down 0 is going to detect when the mouse button, specifically the left mouse button, has been clicked, it is going to generate a raycast hit object, which is going to be an object that's going to store the information about the raycast and what it hit. This function here, this if conditional physics.raycast, is actually responsible for sending out the raycast from a specified location, and that specified location is the gunTip.transform.position. And then, given the position, it asks you, what direction do you want me to go from that position? Well, I want you to go along the z-axis, which is going to be our forward-facing axis, so directly out from the gun. And then I'd like you to put this information inside of the hit object so that I can use this hit object that we have defined here to be able to either get the name of the object, call a script on the object that the raycast hit, etc. And finally, how far do you want this to go? And I believe we set it to something like 1,000 or 100 inside there. That is a public variable that you would change on the inspector. And in here we actually did health equals hit.transform.get component health. If health is not equal to null, then we called the health.takeDamage, and we applied the gun damage to it. Now, in this case, it doesn't matter whether or not the raycast has hit the target. If you shoot a gun, it's going to make noise regardless of what it hits. So we're not going to want to put the audio source.play inside of the if statement. We're actually just going to go ahead and we're going to throw it down here, and we're going to say audio source.play. So that will work perfectly. Now let's come back to Unity and we'll set up the audio source now. So we need to remember where we put that gun script. And if I do remember correctly, we put it on my sci-fi gun light blue. So this is where we're going to add the audio source. So we'll go audio, and it'll be the very last option in this list. And for the purposes of this, we're going to go ahead and leave most of the settings the same. The only thing that I really want to change is the play on awake. So if you were to leave the play on awake, put your bullet shot sound in here, the second you press play, it's going to make the bullet sound, right? We don't want it to play on awake. You'd want it to play on awake if you were having like background music, so that once the scene starts, it can continuously play in the background and on awake. We're not going to want that. I also don't want it to loop, so I don't want it to be like a machine gun where it's like, right, we don't want that. We're actually going to change the volume because 1 is actually going to be very loud. I'm going to bring this down to about 0.1. Sometimes I even put it lower than that. This is just up to you to play with what you would like. We're going to talk about this particle system in just a second, but I'd like you to go to freesound.org. This is a great website that I recommend to students to take a look at various sounds that you can get for free. You do need to register for an account with them. I've registered my account here, and I've used my CMISH email for that. I don't think I've ever gotten an email from them, so you can take my opinion of it. It's perfectly safe to use. And I just search for gun shoot, or you can search for whatever sound effect you would like, and it's going to download a file. This is going to be an AIF file. I'm not sure if you're able to hear that, but it's just the sound of a gunshot. And I'm going to download this, and that's what I'm going to be using inside of Unity for my gunshot sound. So I'm going to go back to my assets folder, and because we like to organize things, we're going to create a new folder called sounds, and we'll go inside that sounds folder, and then I'm just going to drag and drop that audio sound right in there. And now we're going to go back to the gun, and we'll drag and drop the audio source to this position here. And that's actually all that we need to do. Now let's verify that this is working. We'll want to clear the console out just to make sure we don't have any errors going into it. And I like to see all the messages that are generated during play to see if there's any errors that are popping up. So we'll go ahead and play this now. Alright, so now we have our character moving around. Go ahead. Yep. I'm not sure if you're able to hear this through my headphones, but I'm hearing the gunshot sound shoot every time I'm shooting off the gun. So that is a really easy way to get that set up. And I'm going to be making this project available to you as well. If you would like to take a look at what I did for this and reference anything, in case something in the video does not come across correctly, you can always just take a look at the project that I did and compare it to your own. Alright, I'm going to close that out just so I have a little bit more room. So the next thing we're going to look at is instantiating a particle system. So let's take a look at a particle system. So I just searched for particle effect on the asset store, and I just found this one. It's a very silly one. The reason I picked it is because it's a very small size, 2.6 megabytes. I'm going to go ahead and open this up in Unity, and that should open it up in the package manager window here. And I'm going to go ahead and download and import that into my game. Now, of course, you can feel free to use any particle system that you want. Traditionally, you'll probably use like a blood effect. I tried to look for some earlier. I couldn't find any free ones. I personally have some ones that I purchased, but I don't want to use those. I would encourage you to explore what is on the asset store, and of course support all of the amazing content creators out there. They do really create some amazing stuff for the Unity asset store. Go ahead and get this imported here. I'm trying to pick which particle effect I'd like to use. I think maybe we'll do like a firework explosion or just something silly. When the raycast hits the enemy, we're going to instantiate it at that location. So go ahead and wait here. And later in the video, I'm going to be talking to you a little bit about enemy navigation. So specifically, we're going to be using the nav mesh. And that is a very easy way to implement, like for example, wandering AI, and I'll be talking about the complexities of that in just a little bit. Alright, so now that I have that particle system just clear, make sure there's no errors in my console, we're all set now to go back to Visual Studio and to get this set up. So what we just downloaded was a particle system package that is going to contain some prefabs for particle systems that I'm going to want to instantiate when, for example, the bullet hits something. So in this case, we need to create a public game object, and we're going to put that up here. We'll actually put it above our gun tip, just like that. We'll say public game object, and we'll call this bullet hit, just like that. So this is going to be the prefab that we instantiate when the bullet hits something. So let's just see if we can quickly get this working. So we know that when we shoot the mouse button, and we shoot the ray out, this is specifically detecting whether or not it hits something with a health script. I don't really care if it hits something with a health script, I just want to know if it hits something, then we're going to instantiate it. So if it hits something, then we're going to just call the instantiate function. We'll say instantiate, and the instantiate function takes just a few parameters here. It asks, well, what do you want to instantiate? Well, I think I would like to instantiate the bullet hit prefab. Now, if we were to just leave it like this, it's going to instantiate it at the location of this object, which is going to be directly on the gun, which is not something that we want. And if you just space over here after putting a comma, you can actually see what the various parameters are. Again, the parameters are, what does this function need to actually execute correctly? So we see game object, which is the original, so that is what you want to instantiate. We see the vector3 position, where do you want to instantiate it? The quaternion, rotation, how do you want it rotated? And if you want to attach to a transform parent, which is not something we want to do. So I'm just going to say bullet hit, I want to instantiate. I want to instantiate it. Let's just try hit.point. We'll take a look at some of these other ones in just a second, and we'll just do quaternion.identity. Whatever the rotation is of the object, we'll leave it at that. Okay, so instantiate this bullet at the position of the hit.point with its own rotation. Let's just see what this does. So we're going to come back to Unity now, and I need to use my big brain and remember to attach my particle system prefab immediately, because I guarantee you I'm going to forget to do that. So we're going to go back to the project window and we're going to take a look at that assets folder, which I believe is here in the JMO assets if you downloaded the package that I did. Let's take a look at the package structure here. Will probably be in this folder. Looks like we have some various prefab folder. That's what we're going to be interested in. So it looks like we have some various packages here. I'm not sure what these ones look like. Let's do, what do we have here? Let's try Sparks Explosion. Let's see if this works. So we'll go ahead and click back on our object, and we're going to go ahead and just drag and drop that directly in there. So Sparks Explosion B, and let's see if anything happens. When in doubt, run it and test it. Alright, so now we'll take our gun, aim it here. Oh, look at that. That is pretty cool. Even if we shoot it at the ground, it's going to instantiate it wherever your gun actually hit. And this one is really nice in the sense that it is automatically destroying the prefabs. And let me show you what I mean. If you take a look over here at the hierarchy, I'll spam it just so you can see all these different gun clones there. The particle system itself generally will handle the destruction of itself, right? You don't, if you were to fire off 1,000 bullets, you wouldn't want all 1,000 bullets to remain instantiated in your game. Each of those bullets is a game object, which means it has a piece of memory associated with it. And those add up over time. 1,000 bullets is 1,000 pieces of memory, and you gotta remember it's storing all of the vertex information, how to render it, what the textures look like, it's storing any scripts on there, as well as how the physics system is interacting with it. That's a lot of memory that we don't want to be holding on to, especially if you're in a first-person game with up to 16 people or some of these bigger Battle Royale games that can have hundreds of people. We definitely don't want that. So, in this case, it's really nice. You can do something else, and I'm not going to do it here, but I do want to show you how to do it. Something that you can do is you can create a reference to here. So we could say like game object, we'll just call this prefab, is equal to instantiate this. And then if your particle system did not have or does not destroy itself after, X amount of seconds, you can actually call the destroy function, and we can call it on that prefab, and then we put a float in there. So I'm not going to finish it just so you can read that here. It removes a game object, component, or asset, and the float t is going to be the optional amount of time to delay before destroying the object. So if we put 2f, that equates to 2 seconds. So after 2 seconds, it will be destroyed. Now I can't show you this because this particle system already has a destroy effect. It is less than 2 seconds. So before this even runs, the object will already be destroyed. But that is how you would do it if your particle system does not destroy itself. Alright, so that is really exciting. The next thing that I'd like to talk to you about before we get into a little bit more advanced stuff is going to be with respect to how many bullets the gun has. So we're going to go ahead and say public int number of bullets, right? Because right now our gun has an infinite amount of bullets. That doesn't make sense. So we need to check before we fire if we have enough bullets left. And I think this is a bad name, even though I just wrote it. Let's go ahead and change it. Let's create max bullets. So typically if something is a constant, by constant we mean it's not going to change value, public int max bullets, and then we'll say public, actually private, because we don't want any other script to be able to change this. We'll say private int, and this one will be current bullets because this value does change. So if it doesn't change, uppercase, separated by an underscore, otherwise use camel case. And in the start function, we'll have to remember to set the current bullets to whatever the max bullets is, just like that. And now what we need to say is something along the lines of, okay, if the input.get mouse button down is 0, so if the user left clicks and $ampersand, the current number of bullets, so current bullets is the number remaining is greater than 0, right? Then we want to go ahead and subtract current bullets we'll say minus minus, so take 1 away from them, or you could say current bullets equals current bullets minus 1, just like that. So as long as they press down on the left mouse button and the number of bullets that they have remaining is greater than 0, subtract 1 away and do whatever you need. And we want to be able to display this as well. So we'll have to do something. Let's create a text object. So we're going to say using Unity Engine.ui, and let's go ahead and create some text. So we'll actually put this right after here. We'll say public text, and we'll just say display bullet count. Alright, and now we'll be creating a reference to that in just a second. We're going to actually create a function here though. So we're going to create another function. We'll say void update bullet text, and we'll put our parentheses and open this up. So the void function means that it's not going to return anything. And we'll reference our text here, the display bullet count, and we're going to say something like display bullet count.text. And now, how do we want to format that? We could say probably how many bullets we have. So we'll say current bullets.toString, and I want to divide that. Not really divide. I want to put a division symbol between them like that. And then the max number of bullets. So it's basically saying you have this many bullets out of the max number of bullets. .toString. I think that will work. We're going to want to call this the second that that changes. So we're going to put that right there and call that function. Perfect. And we're actually going to want to call this up here too the second that we do set this value right there. So that is perfect. Let's go back to Unity now. We're going to have to create some text on our canvas. So we do have a canvas here, which I believe is referring to, let's see here, that world canvas. I'm actually going to create another canvas just to show you here that you can do that. So we're going to say canvas, and I'm going to call this player UI, player user interface. And we're going to go ahead and right click on that and add some new text. So we'll say text here. We're going to call this bullet text. And then on the gun, we'll go ahead and create that association between the text there and the text there. And we'll set the max number of bullets. Just to show you, we'll do a small value like 5. And we'll make sure that we have this saved so that there's no star up there. We'll come back to Unity and let's go ahead and play and just see what happens. So I can actually see the 5 out of 5, but that's not a very good user experience. We want to make that text a little bit more visible. So let's actually do a few things. I'd probably like to put this in the lower left-hand corner. Typically they'll put it in the lower right-hand corner in most modern first-person shooters, but again, this is your game and completely up to you and how you want to develop it, so put it where you would like it. I'm going to click on this positioning tool here in the rect transform of the bullet text that we have currently selected, and then I'm going to hold down Alt and Shift to position it down here in this corner. You can see the words new text there. Not very beautiful at the moment. I'm just going to put 0/0, and this is just a placeholder. Remember, that's going to get replaced immediately when our gun text script runs, but we just want to be able to see it. And we'll go ahead and just make that a little bit bigger. I need to center this. Maybe not center it. I think we'll just put it right about there. And this is the point in which you can start tweaking values and such. I think I do want to make this a bit bigger though. Now 30 is probably going to go over the maximum size, so you can actually see that it's going to be hidden here. If we go to our 2D mode, I can't see it, and that's because the size of the text box is not adequately big enough to be able to show that. So we'll go ahead and just make sure that that's visible here in the bottom. And what happens now if we go ahead and play, we'll just want to make sure that our 5 out of 5 shows up. Now if we shoot, I can't shoot anymore once I reach 0 out of 5. So that is perfect. Alright, so the very final thing that I'd like to talk about is the enemy navigation. So for enemy navigation, the first thing we're going to do is talk about the nav mesh, which is a tool that you can use. If you look at the window, AI, navigation, so window, AI, navigation, that's going to bring up a new tab for the animation. And I'm going to go back to my scene view so I can see what's going on, and let's zoom back to my player. So we have this map here, right? Now there are many ways to do navigation in Unity. The nav mesh is very powerful. It's included by Unity for free, and for most of the purposes or smaller games you'll be building, this will work just fine. There is another package that I would like to quickly show you. If you take a look here, let's see if I can quickly find it. A-Star Pathfinding is what I would like. So A-Star Pathfinding Project. Now, it's expensive. It's $100. And it's also a very small file. It's only 6 megabytes. So you're paying $100 for 6 megabytes. That's not the way to look at this, though. This is one of the most powerful pathfinding algorithms that you will find, and it works right out of the box for 99.9% of projects. This is good for voxel-based games where the player can edit the terrain in runtime. As you can see here, that character is being able to automatically navigate around this terrain. If you're a very serious developer and want the best pathfinding, I strongly recommend this. I've used it in my own projects. It goes on sale for $50, maybe even cheaper during Black Friday or other sales. I would strongly encourage you to take a look at this one. But for the purposes of this, I'm just going to talk about a free alternative, which is Unity's NavMesh AI system. So what we need to be able to do is we need to be able to bake a navigation mesh. A navigation mesh is a mesh that a character can walk on. What is a mesh for those non-technical folks? Well, we talked about a mesh a little bit more previously in our Pro Builders earlier in this series, but a mesh is essentially an object. It's a collection, right, of vertices which define your faces and edges, and it's essentially just a 3D object or even a 2D object that the player can walk on. Alright, we're going to take a look at the Bake menu here. So if we were to go ahead and click Bake, let's just see if anything happens. So it doesn't look like anything tremendous is happening when we click the Bake. The reason that being is because we need to set up some references. What do I mean by that? Well, we basically have to tell Unity what can this player walk on, what can they not walk on. So let's take a look at this cube here, and we're going to look at it in the inspector. So one thing we need to check here is this static dropdown. So just to quickly read it, this is going to mark this game object as static for all systems, and what that means is it is unchanging, so it's not going to move. So if we mark that as static now, and if you have children game objects, it'll ask you if you would like to change that for all children game objects as well, so you don't have to manually go through each child to change their game objects, which is very nice. Let's go back to the navigation now and click the Bake, and now we have a blue nav mesh show up. So just to recap what I just did, we clicked Bake the first time, nothing showed up. The reason why nothing showed up is because Unity doesn't know what is walkable and what is not walkable. To make something walkable, you have to click the object, which was the cube 1, in the inspector, and select static, meaning it's not moving. Okay, now we have to go through for each of our objects, and we would declare them as static. So, for example, I'll click this tube as static, this plane, sorry, not the canvas, this plane here is static, this thing is static, anything that the player can walk on is static. So this bridge, if I can manage to click on it here, this is static, so is this, and so is that. Perfect. Alright, let's go ahead and rebake our navigation mesh. Anytime you make any changes to the map, you'll want to automatically go ahead and rebake that. And you can see here, wherever there's blue is where your character can walk. So we're going to have to tweak this a little bit. And you can take a look at the settings here. We define the radius of the character. So imagine this blue cylinder is your character. We define the radius, we define the height, we define how high they can step, as well as the angle in which they can climb. So for example, if we were to up this, I believe you can up it to like a value of 60, it looks like. You can see how that changes. It changed it ever so slightly. This is a very steep incline for characters to be able to walk up. The 45 was pretty good. Let's take a look at the step height. We'll bring that up to like 0.8. Bake that. And now you'll notice that the nav mesh is correctly coming up these stairs here. You can even bring that up a little bit further, just to see if we can get this to work. Let's try decreasing the agent radius a little bit, maybe to 0.2. That's looking pretty good. Bring the agent height down a little bit. So now it's correctly going across there, correctly going across the bridge. Now your character's not going to jump up here. It's just saying that these are areas in which it could walk. You can make it so that the character could theoretically go from here and go to the top of this. That is a little bit more complex and outside the scope of this tutorial. This is just a very high-level overview of what the nav mesh system is. I would encourage you to take a look at the Unity documentation for the nav mesh or other tutorials online for that. But we're at least going to get it working here. So, it looks like this is all set up and perfect. I'm going to click on my enemy here. And I'm going to go back to the inspector now that we have that baked, and that'll hide that. And we want to take a look at a few things here. We're going to add a nav mesh agent to this thing. And most of the settings we can keep just fine. Some important ones that you want to take a look at are the speed, whether or not they auto brake, which means they slow down automatically when they get close to their target, and such like that. And what I'm going to look up for is we're going to search for Unity nav mesh follow player, something like that. And we're just going to look for a very basic script that allows the agent to follow the player. So what we'll do here is, this looks pretty similar to what we want. So I think we will actually, yes, let's do this. So I am always constantly referencing scripts that I want to use. What we're going to need is a reference to the player. So let's go ahead and create that. That's pretty important, so we're going to put it at the top again. Public, and we'll say game object, and we'll just call this player. So actually, this is not where we want to put this, is this? No. This is the gun script. This has nothing to do with the enemy character. We're going to have to create a new script. So we will create a new C# script, and we'll call this enemy. It doesn't make sense to put enemy logic inside the gun script. So we'll create a new enemy script. Okay, this looks a lot better. So now we'll say public game object player. And now let's go back to what we were referencing. And essentially all we're doing inside the update function is we need to be able to follow this along. So I'm going to get a reference to the nav mesh agent. So I'm going to say private nav, it's not popping up, so we need to add a library. We need to go to the library and check out a book that says, hey, I need to use stuff from your AI. Specifically, I'm going to be using the nav mesh agent. And we're going to call this, we'll just call it nav mesh agent. Why not? This is going to be referencing the nav mesh agent that is attached to the enemy. So now we actually, now we do need the start function because remember we created a label for it. We need to be able to set that. So we're going to say nav mesh agent equals get component nav mesh agent. Perfect. And just like that here, rather than having to get the component each time, which is a costly operation, we're basically saying, go get this, go get this, go get this. We don't want to do that. we just want to say, I already have a reference to this. I already know about this. I don't need to keep refiguring it out, right? I'm going to say my navmesh agent, and now I can say my destination. Well, where is my player? My player's position. Player.transform.position. So this should be a beautifully simple script. We'll make sure it's saved. Control S. Let's go back to Unity now, and we'll click on our enemy here, and we'll go ahead and attach this. We could have put it on the health script because the health script is attached to the enemy, but that's really bad programming practice, right? We'd want to separation of concern, single responsibility principle. These are all things that if you're a computer science major, you will learn all about. Let's go ahead and add the enemy script. The enemy needs a reference to the player, which is me. So I'm going to go ahead and plop that right down there. And I'm going to decrease the speed because just from my history, I know that this is going to be quite fast. Maybe we'll just try 1.5, and if that's too slow, we can always bump it up. Does anything happen? Let's find out. Oh, Lord, she's coming. Alright, we're going to go to the other side of the map, and she's coming through the tube. Oh, boy. We're running high behind this corner. Oh, she's still coming, though. Here she comes. Now, she's still coming, of course. We'd have to add some logic. And she's actually going to defeat me by pushing me off the edge. No! Alright. Well, what do we want to do? Well, we could probably destroy. That's probably the simplest thing to do. Let's take a look at the health. Now, likely in an actual game, when the health reaches 0, you'd want to, play a death animation or do something fancy. No, we are going to destroy. So we are going to say destroy game object. So now, we'll go ahead and press play. And boom. Oh, that's right, I didn't give myself enough bullets. That is a problem. Alright, let me give myself enough bullets here. That could be an issue. 10 bullets. Each bullet does 10 damage, so I have to hit every single shot. Alright, I think I can do this. Ah, what happened? Oh boy, we missed some bullets. That's not good. I better give myself some more bullets. I'm gonna invoke creative mode here and give myself 50 bullets. Alright, we destroyed it. That's a little bit better. Now, the reason why we missed before, we didn't actually miss. We were hitting the character. The issue was we were inside of the character. And if you're inside the character when we spawn the raycast, if you remember a little bit from our discussion on 3D modeling, a plane typically only has one facing side, right? When we looked at this in the scene view, for example, when we were inside of these boxes, we could see outward, which didn't make any sense because if we were to just go a few feet outward, we could see the wall. It's clearly there. Planes only really have one side that are actually working. And the same kind of holds true for the cylinder. The gun was inside of the cylinder, so it fired forward, but the inside doesn't render, right? When we glitched inside of the character, we could see through the character, essentially, which means that the raycast could go through the character, which means it actually wasn't hitting the character. To be able to solve this issue, we'd have to make the collider of the enemy significantly bigger. And you could just very easily do that by coming over here to the zoom in. We're quite far away. You can see the capsule collider. We can make the radius of it a little bit bigger, so maybe if we bump that up to 2, for example, they're going to collide with us. They can't get very close to us. And you can see that might even be a little bit too close. And looks like we're stuck on there. Oh, there we go. So we're going to have to play with the settings here. We're going to have to play with the radius. And I suspect there's also an issue with the gun collider as well. So I believe that's all we're going to do for this tutorial. If you'd like to see another part, please definitely let your instructor know, and I will continue to create these awesome tutorials for you. It is so much fun to be able to see all of the exciting things that you can do inside of Unity, and I hope this very bare bones basics gets you excited for all the things that you can do inside of Unity, and really you're only limited by your imagination. If you have any questions, please do not hesitate to reach out to either me in the comments section below or to your instructor for further help. Thank you very much.